We're asked to classify each of these solutions as acidic, basic, or neutral. If we have a high concentration of hydrogen ions in a solution, that's characteristic of an acidic solution. If we have more hydrogen ion or hydronium ions compared to the hydroxide ion concentration, we're assuming this is all at 25 degrees Celsius. So if the hydrogen ion concentration is greater than 10 to the negative 7, which is how much you have in pure water, then we have an acidic solution. Right? And if we have a hydrogen ion or a hydronium ion concentration that is less than 10 to the negative 7, then that means we have more hydroxide, so that's a basic solution. We don't really need to worry about the coefficient, but if we look at the magnitude of the exponent, that's a very, very small number. That's right here. That's a very small amount of hydrogen ion concentrations, way less. We're going to have way more of the hydroxide, so this is going to be basic. Let's actually go to C because we're talking about hydrogen ion concentration, so it's already set up here for that. Now, this one, it's a little trickier because the exponent is the same. We've got to use the coefficient. In this case, it's slightly more than 1, a tad little more than what you would find in pure water. Right, so this is going to be very slightly acidic. Let's go back to B and do that one. Now for the hydroxide ion concentration, let's put a scale up for that. Because the product of the hydroxide and the hydrogen ion concentration is equal to the ion product constant, which is 10 to the negative 14. All right, so if we have more hydroxides than what you will find in neutral water, all right, so if we have more than 10 to the negative 7 hydroxides, then that would be basic or base. And if we have less than that, that means we have more hydrogen ions, and that therefore it would be acidic. So if we don't have a lot of hydroxides, that means we have more hydrogen ions, and therefore it's going to be acidic. All right, so if we look at this, we can just disregard the coefficient because this is going to be priority. It's a big number compared to negative 7. We're going to have way more hydroxide ions. So if we have a lot of hydroxide, that's characteristic of a basic solution. Finally, it didn't matter whether this was the hydroxide ion concentration or the hydrogen ion concentration because you can notice 25 degrees Celsius, they're going to equal each other. And so that's going to be neutral. All right, so at 25 degrees Celsius, the concentration of H plus and the concentration of OH minus is 1 times 10 to the negative 7, or simply 10 to the negative 7 molar.